Hello, this is Solvents Flow and Or from Digital Systems Lab. This is lab 4 demonstration. We're going to test addition, subtraction, multiplication, bit to bitwise unit, and the shift unit. The first 6 are A, the next 6 B, and then control. Let's go and test addition first. 0, 1, 0, 0, 1 control. So 0, 1, 0, 0, 1, 0, 0, 1 control. If not, let's try something very simple like 1 plus 1. So let's go 1. 1 plus 0, of course, is 1. And if we put 1 on B, we get a 2. And we put 2 plus 1, we get a 3. And so forth and so on. Let's try something else. We do 0 plus 0, we get a 0. 6, we get 2. 2 plus 0 is equal to 2. Let's do 2 plus 2, we get 4 ones. We get a 4. 2 plus 2 is equal to 4 right there. Alright, let's move to multiplication. Multiplication and subtraction. Subtraction is 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now let's try something simple. 0 minus 0, of course, is 0. Let's do 2, 1 minus, let's do 2 minus 1. 2, 3, 4, 5. So it's 2 right there, and minus 1. We get a 1, of course. 2 minus 1 is 1. 2 minus 2, of course, is 0 right there. And if we do 1, 2, 3, 4. It's 4 minus 0, of course, is 4. 4 minus 1, of course, is 3. 4 minus 2, of course, is 2. 4 minus 4, of course, is 0. Now we're good. And subtraction is try multiplication. Multiplication is 0, 1, 1, 0. 0, 1, 1, 0. Let's put everything to 0. Multiplication, of course, 0 times 0 is equal to 0. 1 times 0, of course, is equal to 0. Let's do 1 times 1. 1, 2, 3, 4. 0, 1, 1, 0, 0, 1, 1, 0. Like that. 1, 1, 0. Of course, 0 times 0 is equal to 0. 1, 2, 3, 4, 5, 6. 1 times 0 is equal to 0. 1 times 1 is equal to 1. 2. 2 times 1 is equal to 2 right there. And this is still at 1. 4 times 1 is equal to 4. Put 2 times 0 right there is equal to 0. This is at 2. 1, 2, 3, 4, 5. This is at 2. 0, 1, 2. 2 times 1 is equal to 1. 2 times 2 is equal to 4. 2 times 4 is equal to 8. Alright, we're done with multiplication. Now let's test bitwise. I'm going to test the easiest bitwise first, which is, let's put the control first for bitwise not. I'm going to test not first because it's the easiest one. 1, 0, 0, 1. It's going to be 1, 0, 0, 1. Of course, all the lights are on because my inputs are at 0. It does the opposite of my inputs. So there it is. Whenever I switch down, it does the opposite of this. If I put this to 1, of course it goes off. If I put this to 1, of course it goes off. Now let's test the AND. The AND is 1, 0, 1, 0. This is 1, 0, 1, 0. Of course, both inputs have to be a 1 for the output to go on. So just because this is at 1 doesn't mean the output is gonna go at 1. So the first let's do 0, 1, 0, 1, 2, 3, 4, 5, 6. So this is at 1. Of course, the output is off. Of course, when I push this 0, 1, 2, 3, 4, 5, 5, and then 1, 2, 3, 4, 5. Well, of course, they're both at 1. The input's gonna go at 1. If I turn this on, it's gonna go at off. If I turn this on, both inputs have to be at 1 for the input to be at 1. So if I put 1, 2 on, 3, of course, both of them on, and two of the inputs are on right there. Now let's test the OR. The OR is 1, 0, 0, 0. So it's gonna be 1, 0, 0, 0. The OR, only one of the inputs have to be a 1 for it to be a 1. So I could put this on, it's a 1 because this is at 0, and then so forth and so on. I could just put these at 1 just because only one input needs to be at 1 for it to be a 1. So I can put this at 0 and put these at 1. Of course, they're gonna light up because only one of the inputs needs to be at 1 for the output to go on. Now let's test the XOR. 1 0 1 1 1 0 1 1. For the XOR, it does the opposite. So whenever the inputs are different, then the lights go on. Just because right here this is on and this is off, of course the output's gonna go off. The output's gonna go on because the inputs are different. This is at 1 and this is at 0. If I selected this 1 0 0 for the XOR, it's 1 0 1 1 1 0 1 1. Okay, and right there, if for the XOR it does the opposite. So if I do 1 on here, this is a 0, so of course it goes to 1. But if I turn it 1 2 3 4 0 1 2 3 4 5, so if I turn it on, because both inputs are at 1, the light go off. Let's test the shift. Let's test shift left first. 1 1 0 0 1 1 0 0, and I'm gonna put my shift at, I'm gonna shift by 2 for simplicity. 0 0 1 2 3 4. Just do 0 2 3 4. I'm gonna shift by 2 for simplicity. 1 2 3 4 1 2, and the shift is 1 1 0 0. 1 1 0 0. Shift 1 2 3 1 2 3 4. There, I shift to the left. It shift to the left by 2 right there. Then it shift to the left, and it shift to the left, shift to the left, shift to the left right there, and it shift to the left, and it shift to the left by 2. Now let's try shifting right. Shifting right is 1 1 0 1. It's 1 1 0 1. I could do, I'm just going to keep it at a shift by 2 just to keep it simple. It's too far over. 1 2, it shifts by 2. 1 2, it shifts right there. 1 2, it shifts over. And 1 2, it shifts over. Now let's test the last one. Okay. Now let's shift the right arithmetic, which is 1 1 1 0 1 1 1 0. This one, there it is. Works in his own way. The first 2 inputs. There it is. Nothing happens. Nothing. There it is. It shifts over. And it shifts over. And there it is for the arithmetic. Shift right arithmetic. The shift to the right. There it is. All right. That's it. Thank you so much.